All right, ladies and gentlemen, we're going to finish up the chromatographies here. We have 3 more chromatographies. We're going to start on the left with affinity chromatographies, and it is what it sounds like. Affinity is about a substrate and its ligand or receptor. So on the left, we have this empty test tube here, this empty vessel, and it has these receptors. These receptors, if we zoom in, are only going to be attracted to one specific substrate, a triangular looking substrate, which is going to be the red here. The red is going to be attached on there. So if we put the triangles, the circles, and the squares in, not all of them are going to stick, okay? So the affinity chromatography has a specific binding affinity to only one of these substrates. So as we can see, the red triangles get stuck, and the square and the circles go through, they elute out. Now, how the heck do we get these triangles out afterwards? So effectively, if we're running this test, we do not want the green and blue. We don't want the squares and circles. We want to filter those out effectively. So by binding only the triangles, okay, that's what we want. But then how the heck do we get them unstuck from that? We put in another substrate that has a higher affinity than the red triangles. So these red triangles here have a little extra part to it, maybe like an alkane chain sticking out to it. So it's not the best. It's not the most specific, highest affinity substrate for these receptors. The red triangles are really, really good. They're not the best. So we're going to bring out the best. We're going to bring in these purple triangles. Those are the best. They're going to come in and they're going to kick out these red triangles here. And then the red triangles are going to fall into our beaker where we can collect them. So these red triangles are going to fall into a beaker where we collect them. That's what we want. Okay. The next is ion exchange chromatography. There are 2 different types of ion exchange chromatography. There's cation exchange chromatography and anion exchange chromatography. We are exemplifying anion exchange here. Okay, so from how it sounds, we're dealing with ions this time instead of substrates. So we're going to put in anions and cations. And with anion exchange specifically, it's going to have the stationary phase as positive charges. Okay, so the anion exchange chromatography, the anions are going to get stuck in there. The anions are going to get stuck in there, and the cations are going to elute through. Okay, so whatever type of exchange chromatography it is, that's the one that gets stuck. So if it's anion exchange, the anions get stuck. If it's cation exchange, the cations would get stuck. Okay, so same thing with affinity chromatography. Okay, we have successfully captured the anions. Now we want to put them in our beaker. We want to take them out of there. So we put even stronger anions in next to kick out the red anions. So the purple are kicking out the red, and then we can collect the red in our test tube at the bottom. Okay, so that's ion exchange. We're going to go to size exclusion chromatography. Now, this one is not intuitive. Okay, so size exclusion chromatography, we're putting in parts, we're putting in substances of different sizes. So we have the big green ones and the small blue ones, and inside of this chromatography, inside this tube here, we have these big beads. So these big circular beads, I kind of blew it up so we can see closely, but there's all these beads in the chromatography there. And we might think intuitively, okay, the small ones are going to elute out first because they're so small they're going to get through the beads, and the big ones are going to elute last. That's actually not what happens. It's pretty counterintuitive here. So the beads, these big circular beads here, actually have little canals in them. So what happens is the little beads, not the little beads, the little substance, the blue circles, those get stuck. They get trapped in the canals. But the big circles can go around. They can go around these big beads here, and they are going to elute out first. Okay, so a little counterintuitive with this one, but with size exclusion chromatography, the big ones are going to elute out first. Okay, like, comment, subscribe, leave some comments down below, guys. Tell me what you think. See you in the next video.